So thank you very much for waiting. Welcome to my talk. It's going to be a weird talk a little bit. It's intended to be funny, so that's a disclaimer. If it's not funny, it's because you don't have a sense of humor. Okay, so clearly it's going to be very funny. There's going to be a lot of Rick and Morty references, so if you don't know the show, you should definitely watch it. It's hilarious. They can be a bit rude sometimes, and if you don't understand the joke, just watch the show and then you'll get it like in a couple of months. So we're going to talk about a new Rick and Morty adventure because season 3 has finished. So now all the Rick and Morty fans are waiting for season 4, and it's going to be like a year or 2 years. So we cannot wait for a new episode. So I'm going to make a new episode for you, and it's about Spring Cloud Stream. Who am I? My name is Hubau. I work in Belgium at a consultancy company called Ordina, and I'm a member of the JWorks unit. So we do Java in the backend, JavaScript, TypeScript in the front end with Angular, React, all that kind of stuff. I have a couple of open source small projects. I made a Spring Boot banner generator before the Spring Boot banner was available, so before version 1.3 or something. Just a quick question, who is using Spring Boot right now? All right, perfect. You'll understand everything. So let's get started. We're going to dive into a smaller world, the world of microservices. So we're going to go to the microverse. If anyone saw the Rick and Morty episode, The Ricks Must Be Crazy, he invented this kind of microverse battery, which is like a small, tiny universe. And inside the universe, there are people running and walking on treadmills and generating power for his spaceship. So that's his battery. So he has an entire universe working for him, which is kind of cocky, but it works. So in that episode, they go inside of the microverse, so we're going to do the same. Inside this microverse, this is how he told people how people greet each other. So I don't want to be rude, it's just how we do things in the microverse. I'm not going to do it myself, that would be a bit too rude. But if anyone ever meets anyone in the street and he gives you this signal, it means he saw my talk and he just wants to give peace among worlds. So it's a good thing. So first, the boring part, the technical part, the theory on Spring Cloud Stream. So what is it actually? It's a framework for creating message-driven microservices. So it's built by the Spring Cloud team, and it builds upon all the good things you know about Spring Boot. So people working with Spring Boot, you're going to be, if you want to use streams and messaging, this project is going to really kickstart you and make you move faster. It's heavily based on Spring integration, so people who have used Spring integration can easily migrate to Spring Cloud Stream. And as usual with Spring Boot-based projects or libraries, they have a very opinionated configuration of, in this case, message brokers. So this is a big Spring Boot concept, right? They configure everything, or they try to configure everything automatically for you. And if you don't like the current configuration or the auto configuration, you can override the beans, you can override the configuration, and you could tune it to your choice. So that's the ease. You can get started with Spring Cloud Stream really easily. They offer this concept of persistent pub/sub semantics. So I'll tell you later a bit more about what that really means. But basically, it's all based on a publish and subscriber pattern. They support different kinds of middleware vendors. The two officially supported ones are Kafka and RabbitMQ. And they have community binder implementations for JMS. So for example, ActiveMQ, they have binders for Redis, AWS Kinesis streams. And I think also for Google pub/sub, but that is not really working very well. They need some people to fix it. So, a really basic example of a Spring Cloud Stream application. Many of you will already recognize it. You just annotate your main class with Spring Boot application. That's half of the work already. Second one is the most important one for Spring Cloud Stream, is you want to enable a binding implementation. So you want to enable a binding to certain channels. In this case, this is the default. The default binding class is called sync. So a sync is like if you open the water faucet at home, the water goes out and goes into the sink. The same thing for a source. A source is where the water comes out. A sink is where the water goes away. So there's two types. This is regular Spring Boot kickstarting code, and the stream listener listens to input, and this is actually called the input channel. It's just a string. People get really confused in the beginning. What's the sync.input? It's just a string called input. And then you can start processing messages. So this one will already start processing all the messages that go on the input channel. The cool thing about Spring Cloud Stream is it offers reactive processes as well. So you can enable the auto configuration, enable binding, and you can just define your input and your output as a flux. So this way you can work with all the reactive goodies from Spring Reactor. And it's really easy to make your Spring Cloud Stream application completely reactive this way. So if you want to make a little bit more complicated example, for instance with RabbitMQ, the only thing you have to do, as usual in Spring Boot, you declare your Spring Cloud Starter, in this case Spring Cloud Starter Stream Rabbit. And I want to have like a REST endpoint, so I added the Spring Boot Starter Web. If you're using JMS, you know by default, Spring JMS, by default they are using queues. But if you want to publish subscribe, you want to have topics, right? So when you're using JMS, there's one property to set. So big change when you're using JMS, one property that you indicate that you want to use topics instead of queues. And this is the binding that you define. So this is your own binding, and you define an output channel. Default, it's the name of the method. So default, it would call output, but you can override and call it another name. So now the channel is called some output. If you want to do something with it, this is the same as before. You define Spring Boot application. I put it all in one big class. So you have a REST controller. You enable the binding to your interface. And then it's just a matter of auto-wiring the channels. For example, this one is defining a REST endpoint. The REST endpoint gets a message. So if I send messages, it will go to that channel, the output channel, and it will send a message through a message builder. This is the listener, so it's in the same application. It doesn't do very much, but this one listens for messages on HTTP REST endpoint, and it sends to the output channel a message, the same content. This is the listener on the some output input channel, some output channel, and it receives the message and it prints it out. So this is really basic. So if we want to create this, we'll just go to what's the happiest place on earth? Does anyone remember? Start.spring.io. So if you listen to Josh Long's talks, we'll just take all the defaults and we'll add Rabbit, Stream Rabbit, and Web. And I'll call it JavaDay. Generate a project. Open the zip. I'll just JavaDay. Oh. This one, right? Whatever. Come on. I'm messing everything up. It's okay. I'll just go here. Start. Downloads. JavaDay. Come on. Don't look at my pictures. Don't look at my pictures. It's fine. It's fine. JavaDay. Just open it. Come on. It's going to load some stuff. So it's basic Spring Boot application, and I just added, I'll put it on big view. So 158, it has a specific Spring Cloud version. It's the Dalston release train for Spring Cloud dependencies. And I have the Spring Cloud starter stream rabbits and Spring Boot starter web. So that's what we wanted, right? I'll show you the main class. So as I said, just add REST controller, and we'll add enable binding for my output channel. Wait, I'll make it bigger. Like that. Come on. And I'll make the interface. And I'll declare an output channel. Oh, sorry. Message channel. Output. So you're just defining an interface with inputs and outputs. And Spring Boot at runtime, or Spring Cloud Stream, will make a proxy around of this interface, a proxy implementation, and it will implement this output channel function. So what we do here, so what did I say? Get mapping. I don't want to do anything, and I want to get a message. I'll get a request parameter called message string message. And when I'll just define the private final, my output channel. So because it makes a proxy of this at runtime, I can just auto-wire it. And I can do my output channel. I have my output. Because you can have multiple inputs and outputs, you'll see in a minute. I can just have message builder with payload, a message build. That should be it. And then I can define a stream listener in the same application where I listen for this message, and I'll print it out. Yeah, it's complaining here that it cannot find the bean, but it's fine because it's not defined as a bean. So IntelliJ goes weird. And so if I start this, so you'll say, how does he know? Oh, sorry. Sorry. I'm missing the declaration of the thing, right? What was it called? Yeah, I have to, of course, specify the output, right? I'm listening to this output channel. So it's going to go over RabbitMQ. You're going to wonder, where's this RabbitMQ? It's just running in Docker on my local machine. So it should start up. There's already something running on port 8080, duh. So I'll just stop my demos here. And come on. And I'll just rerun this. So on Docker, I have a regular RabbitMQ image, just pulled it from Docker Hub, running it locally. Spring Boot takes all the defaults, and the default is localhost default RabbitMQ port, so it will connect to RabbitMQ. So now if I go to Postman, and I do a get to localhost 8080, hello, JavaDay. I don't know how to do spaces, so I just underscore. as you can see here, that's the message. So simple as that. I'll stop this one. Back to the presentation. So what's the advantages of having this kind of model, of having message-driven microservices, microservices who wants to be decoupled from each other? What are the advantages of using this kind of system? So because it's a publish-subscribe model, it's really easy to add different consumers completely decoupled from each other and just consume the same streams of data for other purposes. So for example, this is coming from the regular Spring Cloud Stream documentation. It's a very simple example. We have some kind of application that is producing HTTP, pulling in HTTP requests, and it's putting all these requests, or it's doing something with the data, and it's putting all the data on a topic called raw sensor data. Then we have two consumers, two consuming applications. One is calculating the averages of these data. The other is just ingesting the data and writing it to file or some data store, whatever. This application is going to publish the averages on the averages topic or channel. And for example, this application is going to take all the averages and it's going to keep track of the top 5 or top 10 records. So that it can produce to another channel all the hottest averages or the hottest of the averages. If we would like to add an application this architecture, we don't have to change any of the existing applications. We just put a second application next to it. For example, for figuring out fault detection, maybe there are some averages that go too high or too low. We want to detect this, we create a new application, and we subscribe to the same topic. This means that it's going to pull in the same data and can process them like it wishes, as it wishes. So that's an easy model, right? Everyone can understand this. So the data is broadcast through shared topics. It reduces complexity between producer and consumer. The producer doesn't know necessarily who's going to consume the data, and the consumer doesn't need to know who the other consumers are. They are not affecting each other. New consumers can easily be added. Reduces the coupling, because that's why you want to have microservices. You want to evolve at different rates, and you want to add microservices, remove microservices when they are no longer needed. So we're not using monoliths here. And so that's the main advantages. Put this away. Another feature that Spring Cloud Stream actually took from Kafka, it's a good concept, is the concept of consumer groups. So consumer groups are groups of applications which take the set of data as a group. So they don't take this data. For example, if there are 1 million messages on this topic, this group of applications will consume 1 million messages, and this group will consume 1 million messages. These two members of that group, they will, for example, have each 500,000 messages. So it's really good for scaling out or splitting up the workload. And it's really good for when you want to have another consumer group, it will still get the same amount of data. So it's very similar to Kafka consumer groups. It's a great concept. All the groups subscribe to a given destination, and they all receive a copy of published data. So the group receives the copy. Only one member receives the actual message. And the default behavior, if you do not define a group, Spring Boot will help you, of course. Default behavior, every instance is an anonymous single-member consumer group. So if you would not define nothing for this one, and you would just consume, if you only had one instance, this instance would be its own group. So that's how you should think about it. So let's start with the fun stuff, or at least for me. We have a use case for our demo. And if you saw Rick and Morty, you'll know that Rick gets pretty obsessed with the Szechuan sauce. There's been a lot of stuff on Reddit and the internet about this Szechuan sauce. McDonald's, I'll tell you later. So I hope I have sound. Let me just restart it. It's very important. Everything. delicious. Okay, so this is the basic idea. McDonald's last month actually brought back the Szechuan sauce in limited edition. There were thousands of people in America lining up for the Szechuan sauce, and in most McDonald's, they only had 30 packets of sauce. So they were going crazy for this sauce. It was, yeah. Wars have been started for this kind of stuff. So that's the basic idea. Rick wants to get his hands on as much Szechuan sauce from McDonald's. So let's look to Rick. He's obviously a genius. He invents a lot of cool stuff. He's also an asshole. He's Morty's grandfather. So in the series, he's his grandfather. He's the inventor of the microverse, where we are right now. He invented interdimensional travel. It's pretty cool. And he invented this butter-passing robot, and that's its only use. So it's kind of bummed out about that. But he clearly wants as much of that Szechuan sauce as he can get, but he's a bit too lazy and he's too much of a genius to do it himself. Right? So let's look at him. Rick is a microservice, of course, in the microverse, and he wants to send all his messages or all his requests over RabbitMQ. He's a genius, but he thinks, yeah, RabbitMQ is pretty good. So he's going to listen as well to RabbitMQ, and he's going to listen on the Rick channel. So if we send stuff to the Rick channel, he's going to pick it up. He has also some output channels, namely outputting to the microverse. He's going to output to Meeseeks. We'll get to him later. So we'll have a look how this code is made for Rick. So Rick is the same thing, Spring Cloud Stream microservice. It has a bit of code, and that's about it. There's a bit more coming. Basic thing, every time you define a Spring Boot application and you define the binding for your input channels, output channels, you can organize this as you want. You can put everything in one interface, but whatever. I made it to make it really clear. I have an interface for input channels. As I said, we are listening on the Rick topic. So we define an input, and you can use message channel, but you can also use the subscribable channel. So you can obviously subscribe to this channel. We also have output channels, exactly the same thing. We can output to the Meeseeks topic or channel, and we can output to the microverse. There's one more thing, of course. We have the Szechuan sauce finder bean. It's just demo code, so it's quite ugly. This is very evil code because Rick is evil. We have a static Boolean defined, which is false. And whenever we send to a certain REST endpoint, just a GET request or something, we start searching, and we enable searching to true. So when searching is true, we're going to spam the RabbitMQ with a lot of messages. So we start at 5 seconds for each message, and then after a while, 5 seconds, if he still doesn't have his Szechuan sauce, he's going to go a bit faster. So every time we have this nice, really nice sleep here. And then we cut the time, for each request, we cut the time with 200 milliseconds. So 4.8 seconds, 4.6 seconds, and then it keeps going until we have the minimum interval, which is, I think, 50 milliseconds. So after a while, we're going to be sending every 50 milliseconds, so 20 per second, to the RabbitMQ. So we're really going to stress it. And when we send a REST endpoint, I don't know, a post request or something, we're going to stop searching. So this is the fun part. As I said, input channel and output channel at runtime will be proxy implementations, so you can just auto-wire them. We keep track of the output channels, but the input channel is fun. We have the Rick input channel, and as I said, we can subscribe to it. And then we have this nice little lambda here. And the lambda is a message, and the message is, in this case, a glib glop. If you don't know what glib-globs are, you should look it up. It's quite rude. So we have an ugly if statement. If the glib-glob is all done, coming from the other microservice, then we just send a message, wobble-up-dub-dub. So then he's going to be very happy because he just found his Szechuan sauce. So that's basically the Rick application. So who's going to consume all these messages? We have a perfect victim. We have Mr. Meeseeks. They're not gods. Yeah, okay. So we get it. So, come on. Come on. Yeah, okay. Stop. Please stop. Okay, because it keeps going for a while. So, welcome to Mr. Meeseeks. If you saw the show, it gets pretty intense. Mr. Meeseeks is spawning other Meeseeks, and other Meeseeks they're spawning all over the place, so it's cool. He was invented by Rick. He is summoned by the Meeseeks box. So we have the box. Next week on Devox, we're sponsoring Devox, so we have a booth, small booth. We don't have a lot of money. And we have 3D printed a Meeseeks box with a big button. And if you press the button, it's going to send the REST request. There's like a Raspberry Pi inside. We send a request, and we spawn a Meeseeks in my demo. But the demo is for the end. You'll see. It's pretty cool. So if people come to Devox, come by our booth. It's a very magical creature. It's spawned for a single purpose. In this case, find me some Szechuan sauce. And it disappears once the task is complete. So when we found the Szechuan sauce, we want to kill all the Meeseeks. Same thing. Input channel, he's listening on the Meeseeks channel. So Rick is going to output to the Meeseeks channel. Meeseeks is going to have input Meeseeks channel. He also sends stuff out to the microverse. He wants to die. Existence is pain. Hey there, I'm Mr. Meeseeks, so he's going to spam a lot. And he also sends back to Rick when his request is finished. So he's going to really loud say, all done, when he's finished. But the most important one is he's going to send requests, and a lot of requests, to the McDonald's microservice. I don't know if I have enough time, but basically, the Meeseeks microservice is exactly the same thing. So it's once you have made one, it's almost every time is the same thing. So it gets pretty boring. We're gonna have a Spring Boot application. We're gonna enable binding for the input channel, the output channel. And then we have some scheduling because every 5 seconds we're going to really loudly say, I'm Mr. Meeseeks. So input channel, output channel is the same thing. I'm not going to show that. And I'm just going to show you the Mr. Meeseeks routine. This is the yelling of life is pain, existence is pain, I'm Mr. Meeseeks, so that's every 5 seconds. If you have a lot of Meeseeks, it's going to be a lot of messages. And my very nice demo code, if, else, if, else, if, else. If we have more messages, we just copy-paste another if, else, if. So it's quite cool, right? It's easy. Best code ever. And so he just checks for all the different kinds of messages. As I said, very nice code. And he sends out messages to the microverse, to McDonald's, so it's some orchestration going on here. Quite easy still. And last one that I'm going to show you is the McDonald's microservice. The McDonald's microservice has like this chance of finding Szechuan sauce. As I said, they don't have a lot of sauce, so it's 1 in 500 chance to win. So it's just with a random generator, and if you have the right number, you're going to win. So it listens on the McDonald's input channel, and it sends out on the Meeseeks output channel. I'm not going to show you this one. Exactly the same. It gets boring pretty quickly. Last but not least, we have Morty. Morty is the adorable, cute little guy. So he's perfect opportunity for having him as the front end. because the front end needs to be cute and shiny. So I quickly made something with, I don't even know what it's called again. Vue.js. It was the first time I used it. It was quite cool. And Bulma is like something like Bootstrap, but Bootstrap is boring, so I just Bulma. So Morty is going to take in all the requests, heavy load, from Rick, Meeseeks, McDonald's, and a microverse. So he gets all the messages. So we're going to have to scale Morty a bit, I think. The cool thing, and this is I'm going to show you, is the cool thing is that Morty is receiving all the requests from the RabbitMQ, and he's going to have to expose them, right? In the demo, he's going to have to expose them over the web. So he's going to expose them over event streams. So if you saw Stefan Nicole's talk yesterday about Spring Boot 2, etc., he showed you something about SSE emitters, so server-sent events, media type text event stream. So we're going to use that. So I'll show you in the code how this is handled. We have Morty, our Morty microservice. And it's a Spring Boot application, and I have like some front-end code with Vue.js that get built with, gets built with, what's it called? I don't even remember. The Webpack thing. Yeah, whatever. Doesn't even matter. And we have an application with some input channels. And we're just going to define the 4 input channels. We subscribe to them. So we subscribe to them right here in the event controller. So so it's just a regular REST controller. And when we start up the REST controller, we're going to subscribe to all of these channels, to these force channels. And we have the same handler. So we're going to be sending glib-globs all over the place. So I thought message was stupid, so I used glib-globs. And we have a glib-glob handler right here, which takes in the message, casts the payload to glib-glob. I even found out you don't even have to do this. You can just put glib-glob here, and Spring will take the payload and put it in a glib-glob in a proper class for you. So I don't even have to do this get payload and cast, but I didn't want to change my demo and break it, so you shouldn't have to do it, if I remember correctly. And I have some emitters. So these emitters are a list of, I'm keeping a list of SEE emitters. So this is for all the users that are currently connected to your application in the front end. They go to this event endpoint, and they will get back an SSE emitter, and Spring MVC will, if you put media type text event stream, Spring will keep open the HTTP socket and send everything over the event stream. So if someone new connects, I add them to the list of emitters, and when I get a message, I loop over all the emitters and I send to all my current subscribers on the web. The error handling, must warn you, the error handling is really crap. Usually when a connection is broken or someone clicks away the browser, these on error or on completion or on timeout, I just remove the emitter. So it's not really production-ready code, but it works quite well for the demo. So to put everything together, let me show you the microverse. I have my Rick microservice. I have Mr. Meeseeks. I can scale Mr. Meeseeks. And the fun thing is, I defined Mr. Meeseeks as a consumer group. So, as I said, it's quite easy to define an application as part of a consumer group. The only thing you have to do is, so this is my RabbitMQ configuration stuff for locally and from the cloud, so you don't even have to pay attention to that one. But Spring Cloud Stream, default binder is Rabbit. You don't even need that property, I think. He will detect it automatically. But the most important one is the bindings. And this is the name of the channel. And this is the name of the group. So if you indicate all the instances of the Mr. Meeseeks application, if I have 1, 3, or 5, are all part of the same consumer group. So if he gets a message, one of the instances will handle that message, not all of them. If you don't define this, all the Mr. Meeseeks applications will be part of their own group, and they will all process your message. So then if you do that and you scale Meeseeks up, you will just spam the McDonald's microservice more. So that's not what you want. So it's very important to be aware of these consumer groups if you want to split the workload. So this is my grand architecture. And of course, I need my Meeseeks box. So I have a Mr. Meeseeks box, a Meeseeks box microservice with a REST endpoint where I can spin up more instances or scale down my instances to 0. I'm running everything in the microverse, but it's basically the Spring platform, the Pivotal Cloud Foundry platform, where I'll show my demo. First, let's just run it locally. I have my dashboard here. So this is an addition to IntelliJ recently. It's really handy to just start all of your applications at the same time. So as you can see, it's all regular Spring Boot applications. They start up relatively quickly, depending on your machine. And I think we're done. So we have them running on port 8080, 81, 83, 84, and they're all connecting to my local RabbitMQ on Docker. So I have locally, I should have on port 15,000, yes, the regular login password. So this is the RabbitMQ management console. It comes with the Docker image. You have to use the Rabbit tree management image name or tag, whatever. And then you get this management console for free. As you can see, there are already some queues created. I think there are still some left from the previous one. So they are, most of them are the anonymous single-member groups. So they get like a random name. So some of them are still existing from when I ran the demo before. But if we go to the overview, and then we go to localhost, Morty is running on 8083. So this is my demo. It's quite regular. And you see Mr. Meeseeks, he's already complaining. Exit. So that's one of the messages from Mr. Meeseeks. But usually he'll just complain. And if we do an endpoint, so I'm going to put my sound a bit. So that's him. We'll just go to this endpoint. So I just sent the request so that he will start searching. So he's sending messages. I want my Szechuan sauce. I just want to die. Yeah, he just wants to die. Oh yeah, can do. He sends it to McDonald's. McDonald's says you lose or you win. The annoying thing is, I want to spawn more Mr. Meeseeks because, as you can see, he's getting stressed out a bit, so I want to help him. But we're running locally. Locally is not really a good environment for scaling. It'll go faster and faster, so you'll see the messages going along. You'll see here, the message rate is going up. And the queues should be producing, consuming. You'll see it going all over the place. And yeah, he really needs to find that Szechuan sauce. So we have some buttons here. If you click the buttons, if you click this button, he'll start searching. If you click this button, you'll spawn a new Meeseeks. So let me check. Oh, he's already going quite fast now. So those are the messages being spammed, being sent over the event stream. If I show the network connection, I'll quickly restart. I hope he hasn't. Yeah, OK. You'll see event stream. You'll see all the spam. So event stream is quite powerful. I like it very much. It's sending all the messages, and it's going faster and faster. So now it's 20 per second, but 20 from Rick, 20 from Meeseeks, going back and forth. So there's like 300 per second right now. So that's pretty cool. And he should say wubba-lubba-dub-dub in the end. I should maybe increase the chance of finding Szechuan sauce, because 1 in 500, sometimes it's like that. Sometimes it takes a while. Did someone hear it? It was wubba lubba dub dub. It's a bit quieter because of the Mr. Meeseeks, but it's ready. Yeah, all done. So now we're running locally, so he cannot kill locally. I can kill the process, of course, but he's going to keep running, so he's going to keep complaining. I'm going to shut it down, and we're going to show this in the cloud so everyone can see on their own device. So I'm going to go to the Pivotal Web Services. It's like the it's like Pivotal Cloud Foundry, but just as a service. You can just create an account. You have a free account for 30 days or something, and you just have to pay for the amount of memory that you consume. But you have only 10 or 25 gigabytes. So we have the microverse space. I hope it's not too small. And I have my 5 applications right here. As you can see, Mr. Meeseeks, if you can see it in the back, it's 0. So 0 instances of Mr. Meeseeks, and 1 for all the rest. Oh, no, 2. I already scaled up Morty a bit. Morty is going to have a heavy load, because the more people that open their device, the more you're going to fuck up my demo. So I want everyone to see the demo, but like maybe on 1 device or 2 devices. No, everyone can look at their own device. We'll see how good it goes. These are the endpoints. So if you go on your device to RNM from Rick and Morty, rnm-morty.cfapps.io, then you'll see this screen. It's very quiet still. We're not searching for Szechuan sauce yet, and there are no Meeseeks. So if someone wants to click the image, you're going to spawn a Meeseeks. RNM from Rick and Morty dash morty.cfapps.io. So can I zoom in here? No, I cannot. rnm-morty.cfapps.io. You should see this page then. Everyone see the page? Did anyone press the Meeseeks image yet? Just press the image. It's going to spawn a Meeseeks. Someone already pressed Rick, so he's searching for Szechuan sauce. Oh, yeah, okay. Sometimes the messages, there are already 2 Meeseeks, so 2 people clicked already. There's a maximum of 3 Meeseeks. You're not going to extend my resource limit. I have a cap on 3 Meeseeks, so you're not going to... Oh, damn, so many messages. Yeah, so it gets pretty boring after a while. But you see the instances that are taking the messages, 0, 1, 2. So the different instances are taking up the messages. So we'll see if it goes a bit quicker in a bit, how well it holds up. Maybe in the meantime, I hope it doesn't find it too fast. I have a RabbitMQ in the cloud. So it goes quite fast, you'll see. I think we're going to be, either we crash or he's going to find it. But in the meantime, I want to show you the RabbitMQ in the cloud. Yeah, so it's going up. Oh, I think he already found it. Wubba lubba dub dub. So if you want to restart, just click again. And he starts again. So you can keep going, keep going. I'm going to keep this demo up for quite a while so you can show, hopefully if you like it, you can show your friends. And you can keep spawning Meeseeks. Once he finds the sauce, they will scale down to 0 anyway. But I think... So there he is again. So already a lot of people are pressing the images. So this is basically the demo, and I hope you enjoyed it very much. Thank you very much. If you have questions. If you want to see more of the code, or you want to learn more about Spring Cloud Stream, these are the URLs you can. So there's source code, demo, the slides can be found here, and if you have questions, I can answer your questions for money. No, I'm just kidding.